Hi, I'm Tad Otaki. I'm the Chassis Design and Release Supervisor of the Shelby GT500. My team developed the suspension, wheels, and tires and brakes for ultimate track performance on the racetrack, as well as great performance on the road. The GT500 chassis we developed with specific targets in mind. We had to make sure that the vehicle could handle as well as brake and accelerate for the 200-mile-an-hour performance targets that we had. At the bottom here, we have the front brake rotors, which is 380 millimeters by 32 millimeters wide. They are made by Brembo and have incredible thermal capacity and stopping power. This is the valve stem and the TPMS system on the wheel assembly. Down here is what it actually looks like. On the bottom is the TPMS sensor itself. It tells the vehicle what the tire pressure is so it can alert the driver if he happens to lose tire pressure. Specifically for this vehicle, the performance targets, we developed a brass nickel-coated valve stem, which is capable to 200 miles an hour. This is the Bilstein Damtronic damper system. Here you'll see the front strut, here you see the rear strut. What's so special about these dampers is that in the inside, you'll see over here, is the valving mechanism. This is where the driver can control whether the dampers are in a sport mode or normal mode. In a normal mode, that is when the driver wants a little bit of comfort on the streets. This is for everyday driving on the highway, on the city streets, but when he wants the ultimate performance on the racetrack, he can select Sport, which is a higher damping force that he can get. The objective of the Bilstein selectable dampers on the racetrack is to maintain the sure-footedness of the GT500. This is one of the tires that we use on the Shelby GT500. It's a Goodyear F1 Supercar G2 tire. It has great performance on the racetrack because of its great traction in the dry as well as wet. And not only that, it has to be able to take the punishment of running through the corners, of burnouts during acceleration, and high braking forces during braking. The pattern that you see on the tire was developed by Goodyear. They developed this to help wick water away between the tire and the road, as well as give very good wear performance. The sidewall was developed by SVT and Goodyear for handling performance as well as ride comfort. It doesn't matter whether you're on dry roads or wet roads, on the racetrack or public streets, you'll always experience great handling with these tires.
My name is John Pfeiffer. I work with SVT. I'm a senior engineer in vehicle engineering, and it's my job to take the great work that the chassis, the powertrain, and the body teams do and integrate that to make a car that has supercar performance. Today what we're going to talk about is the driveline and aerodynamic improvements done to the GT500. The overall systems here, which are the driveline and the aerodynamic parts on the front end of the Shelby GT500, are the key enablers to go 200 miles an hour. The driveline at those speeds is spinning very fast, and the aerodynamic loads are very large on the vehicle. These parts are all unique to the GT500. These parts were designed with the intent of coming into the Shelby GT500 and the application of the torque and performance that this car is expected to deliver. The first systems that we were looking at were the clutch pressure plate and the shifting systems, the ability to transmit the torque from the engine to the road. The clutch was revised to improve the drivability and the ability to handle the torque and the shift feel. So first off, with the clutch disc and the pressure plate, the clutch disc was increased 10 millimeters to 260 millimeters, and the friction material was revised to handle the heat and the torque and the speeds necessary to go 200 miles an hour and apply over 600 foot-pounds of torque. This is our shift linkage on the GT500. We've revised the ratios, which is the geometry of the shift lever, as well as the bushings to improve the feel. And the critical aspect on the shifter and the clutch system being that those are the two components that the customer feels every day and all the time when they're driving, so that there's a balance between the clutch pedal effort and the shifter feel. So you're very connected to the road and feel like you're integrated with the car. In addition to the shifter and the clutch discs, the system here, the spring and the master cylinder, the geometry and the shape of those parts are tuned to manage the feel. This part, number 6, is our one-piece carbon fiber drive shaft that's unique to the GT500. This drive shaft was highly engineered to handle the high speed capability of the car. The critical characteristics for the customer is that the drive shaft is smooth and transmit power uniformly. The lightweight contributes twofold. It lowers the weight of the vehicle as well as the inertia weight, which allows the driveline to spin up. One challenge on a carbon fiber drive shaft is the interface to the transmission or the axle side. So you usually have a metal yoke, and what we've done unique on this vehicle is we machine these splines and we press into the carbon fiber drive shaft. There's no adhesives. That bond is amazingly strong and can handle all the torque and all the heat you can throw at it. The front fascia on the Shelby GT500 has a lot of engineering in it. The engineering was done to improve the drag and the balance of the vehicle at high speed. The drag reduction allows us to achieve high speeds by reducing the amount of energy that's wasted in pushing the wind out of the way. It also helps improve the fuel economy. It gives us our class-leading fuel economy of 15 city and 24 highway without a gas guzzler tax. In addition to lowering the drag, the aerodynamic improvements also reduce lift and improve downforce on the vehicle, which gives you your stability at high speed. The critical thing on the grills of this vehicle is that we manage the airflow, that it goes into the heat exchangers and leaves the heat exchangers in the manner that we want it to do. Having the sealing on the heat exchangers, the radiator, the intercooler, the oil cooler, and the transmission cooler gets the airflow through the system to get the heat out of the engine compartment and allows you to maintain those 200 miles per hour and the speeds that you want to achieve at the track. The Shelby GT500 comes in 3 configurations. The standard car is the GT500, which has the limited slip rear differential, the 331 final drive, and all of the packages have the same 662 horsepower. Then there's the performance package, which steps up to the torsion differential, which gives you the ability to transmit the torque side to side, more for a racetrack scenario. And then there's the track package, which adds the coolers. It adds the transmission cooler, the engine cooler, and the differential cooler. The most surprising thing when I first drove it was how fast it was without realizing how fast you were going. The perception of speed is amazing.
Hi, I'm Jeff Albers. I'm the SVT Powertrain Program Manager. I'm going to talk to you today about the cooling system of the GT500. I want to start talking about the charge air cooling system. This is a charge air cooler that is in the intake manifold of our 5.8 liter engine. It has coolant that circulates through it via the pump that is sitting up here. That coolant is pumped through a low temp radiator that's mounted out in the front of the car in the lower grille. We needed to increase the capacity of the system because we have so much more heat rejection with the huge increase in horsepower that we delivered with this car. We went after every component of the system. With the charge air cooler, we decreased the pressure drop on the air side of the system, also managed to increase the amount of heat rejection that the part was capable of. Did the same thing on the low temp radiator. It's wider, it's taller, it's thicker, it's bigger in every way. It gives us a lot more surface area to be able to transfer the heat from the coolant into the ambient air. With the increased capacity of both of these parts, we needed to increase the amount of coolant that was flowing through the system. So we increased the flow rate on the pump significantly to improve the overall performance of the system. So that charge air cooling system is the same whether you get the base package or you have the SVT track cooling package. It's there to deliver maximum horsepower no matter how hard you push the car and use the engine. The increased capability of the system that we delivered is a key part of how we're able to deliver consistent performance on the track lap after lap. We don't see a fall off in performance due to the charge air temperatures going up when the air is compressed going through the supercharger. And that's a key part of the driving experience, and especially if you want to be competitive with the car and go out and get that lap after lap performance that is very consistent. Another system that is standard on the car is the engine oiling system. This is the oil pump. We increased the flow capacity on the part in order to supply the piston oil squirters, which were added to keep the pistons cool under the extreme operating conditions that we see at 662 horsepower. That oil is routed out to an oil filter adapter assembly that you see here. On the base car, mounted to this pad, would be a water to oil heat exchanger that would take heat from the oil, put it into the coolant, and then reject it to ambient air via the radiator on the car. This system also routes the oil through the oil filter, and then on the optional track cooling package, it will run oil out to this part, which is the standalone engine oil cooler. It is an air to oil system. There are two major benefits from having this system. One is that its capability for rejecting engine oil is increased dramatically. The other benefit is that by making this a separate cooling system for the engine oil, we no longer rely on the engine cooling circuit to reject that engine oil heat. So by switching to that system, we not only bring down the engine oil temperature, we also bring down the engine coolant temperature. With the base cooling package, we have the engine coolant thermostat that controls not only the engine coolant temperature, but by being connected to the engine oil cooling system, it also controls the temperature of the engine oil. When we go to the optional package and have this standalone oil cooler, those circuits are separate so that the engine coolant thermostat no longer has any influence over the temperature of the engine oil. In order to control the engine oil temperature, we added an engine oil thermostat, which has ports on the bottom that are connected to the oil filter adapter, and an element in here senses when the oil is cold and bypasses the cooler assembly, allowing us to get rapid warm-up of the engine oil. And then this valve will open when the engine oil gets hot so that the cooler can then be used. One of the key reasons for having this in is that if you operate your oil too cold, you have issues with not evaporating both fuel and water that get into the oil. It's critical that you get your engine oil up to certain temperatures so that water and that fuel can be boiled off, keeping your oil clean. Next, I'm going to talk about the optional transmission oil cooler that you see here. This is mounted in the upper grill opening at the front of the car. It's connected to the manual transmission, which on the optional package has an additional feature that's a mechanical oil pump. That pump routes the oil, transmission oil, up to the front of the car through this cooler so that the customer that is in a track use situation is able to keep their transmission at its optimum operating temperature. This system is very unique. Transmission oil cooling is something that is done on automatic transmissions. It's very rare that you see something like this on a manual transmission, and it's something that is really only required when you go to the track and you have that repeated hard acceleration type use that this car can see at the track. That's the intended use of all of these optional cooling systems, is to support the person who likes to go to the racetrack, who will have that very high duty cycle on the powertrain. They're using the 662 horsepower all the time, constant back-to-back accelerations where you're putting tons of heat into all the driveline systems. All right, next, let's move back to the axle cooling system. You see a few components of that system here. We'll start with the finned aluminum cover that is there on all of the cars, both base and optional. It has these cooling fins, which when ambient air is directed over these will reject heat from the axle. More than adequate when you're in typical duty on the street or at the drag strip. If you're going to be on a road course for extended periods, you need additional heat rejection capability. So on those optional cars, we have a couple of extra fittings that have been added here, and also a temperature sensor here. This temperature sensor is used to control an electric axle oil pump, which you see here. This is mounted over the axle to the body. Oil is pumped from the axle cover through this pump. Then it goes through a set of lines that run all the way to the front of the car. And in the front right corner of the car, we duct air to the axle oil cooler that you see here, reject the heat to the air, and send that cooled oil rearward in the car to the axle. Another key part of cooling this fantastic engine is airflow through the radiator and other heat exchangers. We've upgraded the cooling fan on the car. It has an extra blade for a total of 7. We've also increased the power on the electric motor that runs the fan. So the fan itself takes care of relatively low speed cooling on the car, but as vehicle speed increases, you transition to ram air, becoming the dominant influence on air going through the heat exchangers. In order to facilitate that, we've added speed flaps in the lower corners of the shroud of the fan to allow air to go through an area that would normally be blocked. At low speed, when the fan is operating, these draw shut so that all of the air that is being pulled by the fan will go through the heat exchangers. When the vehicle speed increases and you start building air pressure from the ram air coming through the heat exchangers, these flaps will rotate and open up, allowing for even more airflow through the radiator. It's been an absolute thrill to be part of history working on a 662 horsepower engine that sets the benchmark for performance vehicles. It's been exciting working with enthusiasts, delivering a product for enthusiasts. Just an absolute thrill ride the whole way through. So now let's talk a little bit about horsepower. If you're going to make a Mustang that'll go 200 miles an hour, you need lots of power. So let's start with the supercharger. It's the top of the engine, right up in your face, looks great, but what does it do? It pumps air into the engine. In order to make horsepower, you need lots and lots of air. So you've got to get that air into the engine, and that's what the supercharger does. Made dramatic improvements in the inlet area here. The throttle body adapter was changed as well to mate up to that, and we found significant horsepower by tweaking those areas. So all of that pressurized air that you just made with the supercharger is going to go through the head assembly. In order to make that airflow happen efficiently, we increased the lift on both intake and exhaust cams. So all that extra lift on the cams is there to help you flow air and make your horsepower. The rest of the changes that we made on the head assembly are related to making the head and the engine durable, making it live under the extreme operating temperatures and pressures that we see with this engine. So now we've turned the head assembly over so that you can see the business side of things. Here you can see the upgraded exhaust valves. They have a stellite hard face on the seating surface of the valves. We've also upgraded the valve seat inserts in the head itself so that they can also withstand the high operating temperatures and pressures that this engine sees. In order to properly balance the added mass of the 5.8 liter pistons, we had to change the balance characteristics of the crankshaft. We've added a tungsten insert here that you can see pressed in. That gives us a little extra mass so that when we go through the balancing operation, we can achieve the critical balance that is required. Achieving that critical balance is important for this engine that revs to 7,000 RPM and has piston speeds that rival F1 and NASCAR engines. Next, I'm going to move over to the oil pan and the windage tray. This is the windage tray. You can see there's a lot of detail in here. All of these elements are shaped to fit very closely to the crankshaft so that the gaps are very small. We're able to pick up the oil that's flying around inside the crankcase, draw it away from the crankshaft so that the parasitic losses are reduced. That is a facilitator for both better fuel economy and delivering power. This unit is kind of unique in that it's integrated into the oil pan gasket. You can see that the sealing element is molded in on the perimeter of the part. Below it, you see here the cast aluminum oil pan with very unique shape. We took advantage of every bit of package space that we could find below the engine and around the cross member. Reason being that we wanted to increase volume of the oil so that we could keep it cool, so that when you're generating the tremendous power that we generate for extended periods of time, it helps us keep that oil in just the right condition for increased durability. So now let's take a look at our all aluminum block, which is the heart and soul of generating the 662 horsepower that the GT500 makes. Let's start here with the bores. The bore diameter was increased to 93.5 millimeters. The plasma transfer wire arc technology that we used with this aluminum block are key to delivering a very lightweight block, but also providing the durability, which is key for long life of the engine. We end up with a steel sprayed-in liner that is mechanically interlocked with the wall of the aluminum. Gives very good durability. The geometry of the cylinder is very good. It is very true and straight, and allows us to use reduced tension on our piston rings in order to give high performance via reduced parasitic losses in the engine, and also gives a side benefit of improved fuel economy as well. I'd like to point out these passages here as part of the coolant passages on the block. A new feature for the 5.8 is a cross drill between these two passages. It's in a V shape and connects them and provides cooling in this critical area of the bridge between the cylinders. So now we've rotated to the bottom side of the engine block, and you can see here we have 6-bolt billet main caps. They each have 4 bolts that you can see here, and each one has a bolt coming in from each side for a total of 6 per cap. All of that is part of delivering the incredible structural rigidity that's necessary to deliver 662 horsepower and 631 foot-pounds of torque.